Welcome to one more 6Win demo. In this demonstration, we will show how easily 6Win Virtual Accelerator integrates into the NFV environment using Mirantis Fuel to automate the installation. Then we will show 6Win Virtual Accelerator's dramatic improvements in throughput and latency and hardware resource optimization when compared to Open vSwitch. Our setup consists of a Mirantis 9.0 OpenStack environment and comprises a Fuel Master node, one control node, and two compute nodes. Thanks to the 6Win Virtual Accelerator Fuel plugin, there are 4 steps to auto-deploying 6Win Virtual Accelerator. First, if not already uploaded, we upload the 6Win Virtual Accelerator plugin to the Fuel Master node. The plugin and user guide are freely available from the Mirantis Unlock Partners portal. Second, we create a KVM-based OpenStack environment that will host 6Win Virtual Accelerator. Third, we enable the plugin and upload the credentials file provided by 6Win support team. Advanced configuration is available. The 6Win Virtual Accelerator documentation details how to use the advanced parameter section. Since the network setup could differ from one environment to the other, environment network settings should be adapted accordingly. Now we define the nodes that comprise the environment. We can easily select none, a few, or all compute nodes to include 6Win Virtual Accelerator for deployment. We confirm the virtual network configuration applied to these nodes represents the physical link setup between associated physical machines. We come to the fourth step. After adapting the virtual network configuration of all defined nodes, we run the network verification task provided by Fuel to make sure the setup is correct. We now deploy the new environment. Through the magic of video editing, we reduce what takes several minutes to a few seconds. 6Win Virtual Accelerator is now running and ready to deliver the expected performance boost. Now we measure and compare throughput and latency of 6Win Virtual Accelerator and standard Linux OVS. The testbed comprises 2 compute nodes, one with Linux OVS and one that includes 6Win Virtual Accelerator. Both nodes have the same VM, 6Win Turbo Router, to remove any bottlenecks linked to packet processing capabilities of the VM. An Ixia traffic generator generates traffic and measures throughput and latency. Grafana will be used to collect statistics from the nodes. Although we will not show the execution, we use the Horizon GUI to add images and flavors and build the VMs used in the test. After creating the VMs and before running the tests, we make a quick check of the system configuration. And thanks to 6Win Virtual Accelerator's transparency, this check relies on standard Linux commands typically used for this purpose. For example, the IP link command can be used. eTool is also available and can be used on physical or tap interfaces to retrieve interface statistics or other information, and also for debugging. The TCP dump command can also be used anytime for debugging the traffic flow. Finally, we get to our first test, throughput. The Ixia will transmit at full line rate across the 2 10GbE links for this test. We first measure the throughput and CPU utilization of a non-accelerated compute node. Before starting the Ixia, note the top Grafana graph showing 0 throughput and the graph below showing the host CPU utilization during this idle period. We add the Ixia gauges and start the generator. We see the system under test reach its maximum throughput of 5 gigabits per second while receiving 19.7 gigabits per second of traffic. The top graph confirms the VM is transmitting 5 gigabits per second of data traffic. The bottom graph shows that Linux is using 4 cores to achieve 5 gigabits per second of traffic forwarding. The second throughput test uses an accelerated compute node leveraging 6Win Virtual Accelerator. The test is started with the same procedure as the last. We quickly notice that the system reaches full line rate, transmit and receive equal 19.7 gigabits per second. To simplify, that is 20 gigabits per second of throughput. 6Win Virtual Accelerator provides a 4 times performance boost over Linux. We also see CPU utilization is reduced to 1 core and is confirmed by both the Linux graph and the FastPath core graph on the right. That is a 4 times reduction in core utilization, or 3 free cores that can be used for other purposes. The second set of tests measures the latency of the systems under test. Through the magic of video editing, we run the tests side by side, or more appropriately, top to bottom. The average latency for Linux is 112 microseconds, whereas the average latency for 6-Win Virtual Accelerator is 9 microseconds, a dramatic 12 times reduction compared to Linux. In summary, we showed the quick 4-step installation process of 6-Win Virtual Accelerator into an NFV infrastructure using the 6-Win Virtual Accelerator Mirantis Fuel plugin. Additionally, we demonstrated how 6-Win Virtual Accelerator efficiently improves throughput and latency. Specifically, 6-Win Virtual Accelerator increases throughput 4 times while reducing latency 12 times compared to Linux. In addition, 6-Win Virtual Accelerator uses a single CPU core compared to Linux, which needs 4 CPU cores to achieve something less. This translates to a 4 times improvement in VM density. That is all, and thank you for your patience.